Welcome everyone. In this video lecture, we will solve a numerical based on the MOSFET small signal model, and it is basically a common source amplifier based problem. So the question is, a common source amplifier is given. So this one is, I have already made the diagram. A common source amplifier is there which utilizes a MOSFET biased at the ID drain current having 0.25 milliampere, okay, and RD value is 20 kilo ohm, and the VOV, the given thing I am writing here, ID is given 0.25 milliampere, and VOV, that is our overdrive voltage, 0.25 volt, which is basically our VGS minus VT. Okay, it is given, and RD value in the circuit is given 20 kilo ohm, and VA value, the early voltage, 50 volt. Okay, so the amplifier is fed with a source having signal R signal. Okay, how much? 100 kilo ohm. Okay, and terminated with a load 20 kilo ohm. Okay, and it is terminated with a load of 20 kilo ohm. Okay, 20 kilo ohm. So these are the things which are given. Okay, so first of all we have to make the equivalent model by considering this device. Okay, this one is the MOSFET, so we have to make the equivalent model. So what we will do, first we have to make the MOSFET equivalent model. Okay, for this purpose what we will do, source is grounded, so I am making this as a source. Okay, and this will be always our get to source voltage, and some resistance is there. Okay, some resistance is there, that is our R signal. So I am writing R signal here, and we are giving this voltage, AC voltage, VI. Okay, and now for the AC analysis, we have to make this VDD ground. So this point is, this one is our GMVGS. I have discussed so many times this, and this should be our RD. Okay, right now I am not putting this RL because some reason I will tell it later. And one VA is given, means we have to find the, due to we have to use the channel length modulation concept. Okay, if VA is given, then channel length modulation is in picture, is present. Okay, we can write it's present. So we have to find the finite output resistance R naught. Okay, so that R naught is generally defined by VA by ID, or if lambda channel length modulation parameter is given, then the formula will be like this. So in the question, VA is given, ID is given. So very simply we can write R naught value will be, VA is how much? 50. So 50 by 0.25 milliampere means 10 to the power minus 3. So if we solve 50 divided by 0.25, okay, means it should be around 200 kilo ohm. Okay, so this one is the R naught value. R naught value is finally we have calculated 200 kilo ohm. So this one is important here. So we have to put R naught here. Okay, I am writing here R naught. Okay, RL will be also there, but why I am not writing, because in the question we have to first find the input impedance, output impedance, and voltage gain without load. AV naught means voltage gain without load and voltage gain with load. Okay, so first, so that's why right now I am doing for this only. So this one is the R naught value. Now GM is also not known. So GM we have to find. Now transconductance parameter we have to find. So we know the formula like mu n COX W by L, VGS minus VT, or VOV we can write. Okay, so now GM, but ID value is given. So what I am doing, the same GM can be written as 1 by 2 times of twice 1 by 2 2. So it should be cancelled out. So like why I am writing, because I am not remembering the formula VGS minus VT. Here once again I am writing VGS minus VT by VGS minus VT. Okay. So this will give half. Okay. Or we can write twice ID, because this term, this half, and this, and VGS minus VT whole square is nothing but simply ID. Okay, and 2 is multiplication, so 2 will be there. Is it okay? And then this VGS minus VT. So what we will like, VGS minus VT. Okay, means this one is also one formula, means twice ID by VOV. Okay, one formula means, so we can write directly the GM value will be twice ID by VOV. Okay, because this parameter are given VGS minus VT everything. So now what we can do, twice ID is 0.25 milli, so 10 to the power minus 3, and VOV value is also given. VOV is given 0.25 only. So 0.25, because we have to find GM. So GM value is now 2 into 10 to the power minus 3, or GM can be written as 2 millisiemens. Okay, so this one is the GM calculated, R not calculated. Okay, clear. So now GM is known to us, everything is somehow known. Okay, now what we have to do, we have to find the input impedance. Thi- this one, R in, or sometimes we can write Z in. So this one is open, so it offers a very high input impedance, so should be infinite. Okay, now we have to find out the load impedance. Okay, like Z naught. Okay, so now this Z naught will be R naught parallel with RD. Okay, Z naught, or we can write it R naught. Okay, and this point is our V naught. Okay, better to add V naught also. So this Z naught equals to R naught parallel with RD by keeping VGS 0. Okay, so R naught parallel with RD. So R naught we have calculated how much, 200 kilo ohm. So better to write 200 kilo is parallel with RD 20 kilo. Okay, so what we will do, we can write 200 into 20 by 200 plus 20. So 200 into 20 by 220 and kilo ohm. Okay, because kilo and below numerator kilo square by kilo. So kilo cancel, kilo ohm, k ohm. Okay, simple calculation. Now if we solve this one, it will cancel out to 11. Okay, means 200 by 11 kilo ohm. 200 by 11 kilo ohm, or if you solve directly, it will come 18.18, or simply you can write 18.2 kilo ohm. So now the R naught value will be 18.2 kilo ohm. Okay, so this one is important result. Z in known to us. Now this one is also known to us, R naught. Now we have to find the AV. Okay, means this we have already find. This now AV naught we have to find without load. Okay, AV naught we have to find. We have to find AV naught. That is our V naught by V in. Okay, we can say V naught by V in we have to find. So now these two are in parallel. Okay, so V naught value, because once again I am, this one is there, R naught, R naught and RD in parallel, and we are taking output, and some current is flowing like this, GM VGS. Okay, so this one will be simply minus GM VGS. Okay, Means now what we will do, these two are a simple resistance are not parallel with RD, okay, and this one is the current, it is our GMVGS, and this one is one resistance are not parallel with RD, and current is flowing through this, and we are taking output as this point. So the current will be same GMVGS. So this current we can write this current, that is our basically our drain current. This one is our drain current ID. This one is our drain, and some current is AC current, that is our ID is flowing. So this ID we can directly write very simply. ID equals to 0 minus V naught by, because this one is resistance 0 volt V naught volt, and some current is going, that is our GMVGS. So 0 minus V naught by R naught parallel with RD. This one R naught parallel with RD. So V naught will be simply minus ID R naught parallel with RD, and ID is nothing but simply this GMVGS. GMVGS R naught parallel with RD. Okay, so this one is the V naught when there is no load, simply minus GMVGS, and these two are in the parallel. Okay, and from the above circuit, this one is a very high input impedance, so there will be zero current in this one. I of gate will be zero current, so VGS will be same as that of VI. VGS is same as that of VI. Okay, so VGS is same as that of VI. Okay, so what we can write, P naught by VGS is nothing but simply AV naught without load is minus GM R naught parallel with RD. Okay, now we have all the data. GM is minus 2, sorry, 2 millisieverns, so minus 2 into 10 to the power minus 3. R naught parallel with RD. So R naught parallel with RD, that is our Z naught. R naught parallel with RD we have calculated 18.2 kilo. 18.2 18.2 kilo we have already calculated. Okay, this one. Okay, so now it should be simply minus 36.4. 36.4. Okay, and this one is 10 to the minus 3, so kilo this should be, and this should be cancelled out, so volt by volt. So AV naught will be minus 36.4. Okay, simply we can write like this. Okay, this one and this one is the formula we can say, but better to go the step by step process. We have find out this value. Now we have to find the AV naught, AV over volt voltage gain. Now we have to find the overall voltage gain, that is our AV. So that AV is nothing but simply what we can say. This AV equals to with load. Okay. So in this case we have to add both RD, R naught, and one load resistance is also given, RL. Okay. And then same current is flowing like this. Okay, and this voltage. So in this case, we have to take all three in parallel. R naught parallel with RD parallel with RL. Load resistance is given RL. RL is given 20 kilo ohm. This one RL is 20 kilo ohm. Okay. So now in this case, simply AV can be minus GM R naught parallel with RD parallel with what, RL. Okay. So this one is the formula we can say, or directly you can derive. So the value we can find like this, minus 2 into 10 to the power minus 3. Okay. Now what we can write, this RD and RL is same. RD is 20 kilo ohm, and so R naught means RD equals to RD parallel with RL I am writing, because RD is 20 kilo ohm and RL is also 20 kilo ohm. So RD parallel with RL is RD by 2 because both are same. Okay, means 10k. Okay, so we can write it 10k for these two. Means RD parallel with RL is RD into RL by RD into RL. Okay, so plus R1 plus R2 by, then it both are same. So R square by twice R, so R by 2. Okay, very simple. So now R naught is 200k. So minus 2 into 10 to power minus 3. R naught is 200k parallel with 10k. So now we have to solve this one. So this can be easily find 200 parallel with, okay, so what I am writing 2 into 10 to the minus 3. Then what we can write 200 into 10 by 200 plus 10. So minus 2 into 10 to the power minus 3, and there should be a k. So 10 to the power 3. So 2000 divided by 210, okay, into 10 to the power 3. This should be cancelled out. So it should be minus 400 by 21, okay, and if you solve it will come 19, minus 19.04, or simply we can write this AVH minus 19. Okay, is it clear? This one is very simple calculation. Okay, means minus 19. The formula will be this because all these three are coming, are not, okay, GM, so minus time this. Okay, now this one is over. Now last one more point, one more question is there, one more thing they are asking. This one is clear, this one is clear also. Okay, now we have to find the sine wave voltage of the output, sine wave voltage of the output. Okay, when the input signal wave is limited to 10% of twice VOV. Okay, so what it means input is given 10, limited to 10% of twice VOV. Okay, to maintain reasonable linearity. So we have to first write the V signal value magnitude. Yeah, now space is very less, so but so V signal is given 10% of twice VOV. It means 10% of VOV is 0.25. So 2 into 0.25 means we can write 2 into 0.25, 0.5 and 10%. So 10 by 100. Okay, then again 100 means 0.05. So V signal strength will be this. Now AV equals to V naught by V signal. Okay, okay. Then what we can write, the V naught will be AV into AV into V signal. So this AV is now minus 19 into V signal is 0.05. So if we solve this one, it will become minus 0.95. Okay. So this one is the final answer. Okay. This one is the final answer. Means in the question it is given, so we have to find the V signal strength. Okay, then this one is the formula, we can say. So AV is known to us, V signal is known to us. Final result will be like this, 0.95. Okay, means and final V naught will be minus 0.95. So this is all about this question. We have find without load, with load, okay, with load, input impedance, okay, input impedance, output impedance, everything we have calculated. Input impedance is simply infinity, so no need to vary. Transconductance, so we have also derived the formula. What is the transconductance formula? R naught, how to find the R naught we have calculated. Okay, so this is all about this question. So thank you for watching this video, and this problem is basically from the microelectronics circuit school. Okay, so thank you for watching this video.